All right, hi everyone. They did have a step stool up here for me yesterday. It has since disappeared, so I apologize if you can't see me, but I can see you. Okay, so like I said, a common theme today that we're going to be hearing about is this idea that we have unprecedented amounts of data that are being collected in our offshore and coastal environments, which is being done in many ways by all of you out there. And also many of us in this room are thinking about big important questions like how do we use that data to get information for decision making, for education and outreach, to help with the stakeholders that Mark Casey was talking about that include lots of different groups of people, students, regulators, legislators, and so on. And so I'm really excited for today's panel, which includes a whole host of professionals here in the Mid-Atlantic that are operating on this cycle of data. Dr. Emily Shumchenia, who's joining us virtually, will talk more about that. But the first part of our session, we sort of broken this up into two chunks. Well, we're going to hear from three different people in the beginning that are looking at data collection efforts, that are looking at how to synthesize that data to inform state decision making. And then the second part, we're going to talk with Dr. Renee Reilly and Dr. Emily Shumchenia about how we can really manage that data so that, as Nick Napoli, if anybody was here yesterday, Nick talked about this aggregation of data so that it is usable by people who need it. And so the important pieces of that is that the data that we collect are able to be compared across geographies, across jurisdictions, that they are accessible by the people that need to access it. And so we have a lot of great work going on in the region, in large part sort of led in some ways by the regional ocean partnerships, but by other regional entities that are really doing important work on the data management front. So I'm excited to hear about that at the end. So after this first session, we'll open it up for some Q&A for a couple of minutes, and then we'll go into the data management piece, and there will be another opportunity for Q&A after that. So getting started here, I wanted to welcome to the stage Dr. James Rising. He is an associate professor at the University of Delaware, and he's going to talk to us about a study that he has done for Delaware that looks at data gaps off the Delaware Coast. So Dr. Rising, welcome.
Thank you very much. It's a real pleasure to be here. Most of my work is in climate change, and so I don't often have an opportunity to come and connect with people more locally. So I want to tell you a bit about this project to understand some of the data gaps around spatial planning projects that are happening in Delaware and what those can mean for future thinking around this data collection process that we're all engaged in. Just give you a bit of the context, Delaware has been engaged in a really deep Delaware Ocean and Bay planning process to understand the broad opportunities across the ocean and bay, the future of activities there. And one of the features of that is to really understand the needs and connect with stakeholders around them. And so we got an opportunity to contribute to this process. And first, we wanted to sort of understand what the space was being used for. And across, I guess this is a little bit fuzzy, but across the ocean bays, we identified a whole range of infrastructure. There's shipping, there's recreational activities, there's industrial needs, a whole bunch of different activities, and we wanted to try to understand where they were happening as well, because a lot of the key needs for data are around interactions between some of these activities. For what I'm going to talk about here, we split those up into a range of broad categories: fishing and aquaculture, culture and recreation, navigation and transport, military and science, biodiversity and conservation. And then the core work of the data gaps process was to identify spatial data across each of those and try to categorize it into different needs that are important for making some of these decisions. And I'll tell you about a bit of that. We also did a stakeholder survey that fit into our process, and sorry for the overlap here, then dug into some of the spatial and temporal features of the data. We wanted to really understand where in space and where in time the gaps might be, not just more broadly what the data challenges were. So there are a bunch of, it's a shame, there are a bunch of stories that I can pull out of this. What you would see here, if the slide came through, is that there's, we developed a kind of way of thinking about the hierarchy of data needs. And if you think about something like fishing, it's not just information on fishing that we want. We actually want to understand something about the physical conditions that the fish rely on. So understand the biophysical suitability of regions. We need data on that. That then is going to feed into and support data on the abundance of fisheries. So that's going to be our resource data. We also want to get data on that. Those resources are then going to be used, and we want to understand how they're used. What's the catch outcomes of that? What are the what kind of effort is being used across fisheries? Then we want to understand how that use is being managed. What are the different regions that fisheries management is happening around? And that management then produces economic outcomes. What are the what kind of revenue and costs are fisheries facing? And as they look forward to the future, what does that mean for the future of their activity under climate change and the development of new infrastructure and other activities? And so in this way, we're trying to not just understand the different components of data that are going to feed into that particular activity, fishing, but how those components of data build on each other to understand this hierarchy of data needs. And then we can, we took all the available data that we could find on spatial features across all these different activities and categories, including a bunch of fantastic data from marine cadastre. Marco has a huge amount. Google Earth Engine had a fantastic collection, and then also a bunch of academic papers. And across each of those data sets, we want to understand what's the spatial extent and resolution of this data? What's the time coverage? How frequently are those data sets being updated? And then we built a kind of network to connect each of the activities to each of these data sets. And so there's a big underlying network behind all of this data gap work that we did. That's fine. The pieces that you're missing in here are not, I can talk around them, so it's okay. In our first pass through that data, we actually, we collected all that information by hand and reviewed a couple hundred data sets, and then realized, this isn't, we're missing the biggest part of the story, which is data from Marco in particular, and then also the Google Earth Engine, because that was sort of already within the scope of what Delaware had its hands on. And so we came up with a neat system using artificial intelligence to go through and collect all the information on spatial and updating time attributes of the data to feed those data sets also into our data set. And then still used sort of by hand looking at the data to understand how they relate to all these different activities. Okay, so let me tell you a few highlights, a few stories from the outcomes. There's a lot more in the reports that we produced, but then also in an academic paper that we're getting ready. First, one of the things that came out of the stakeholder engagement was the biggest concerns around the future of building out some of these activities was conflict between the activities. What happens when different activities being managed in different ways end up coming into contact, and what does it mean for the future of those activities in Delaware? And now with amazing AIS data, we can understand where a lot of these activities are taking place. This is just a map of one particular year of where ships across a whole range of different categories of ships are. And you can sort of already see some of these key lanes where boats are coming into and out of the bay. And so we could turn that into, for example, an understanding of congestion. What's the, how close are these ships coming to one another, and you know, are they naturally going to come in conflict? And we found that there were actually a bunch of places, not just sort of along these main shipping lanes, but across the Delaware Ocean planning area that have quite high levels of congestion at certain times. And we also found that there were some interactions across different activities. So at the little circle at the top of there shows where fishing and recreation is coming into conflict. At the bottom we have a recreation and shipping is coming in, and to the right where cargo shipping, navigation, and fishing are all coming into conflict. We're also able to come up with some sort of a data gap score. What are the main activities that are most in need of deeper data, accounting for some of this hierarchical understanding of data needs. You can see that we have the most data on fishing, actually quite a bit of data on marine mammals and under our biodiversity understanding, a lot less on some of actually the infrastructure, cooling and water intake. Oyster aquaculture is a little bit of a, it's not so surprising that that's there. There isn't really oyster aquaculture on the Delaware side of the ocean and bay, but maybe that's to some extent because of the lack of information there on the underlying resources. So I'm just about out of time. Just wanted to let you know that we think that there's a direction of movement here to understand how some of this pyramid of data can be better understood, not just as gaps, but actually to understand where those gaps are, when those gaps are, and under what conditions those gaps emerge, and then to try to turn that into some more actionable information around the future of marine spatial planning. Thank you so much for your time, and pass it on.
Thank you, Dr. Rising. That was very interesting. Appreciate that presentation. We now welcome to the stage Jillian Eller. Jillian is a PhD student at East Carolina University. They are a graduate research assistant at the Atlantic Marine Energy Center, and we are an alumni of Temple University. So welcome, Jillian.
Thank you so much, Avalon, for the introduction, and I appreciate the opportunity to speak today. I am here today to talk about my research on a novel stakeholder engagement tool called the Marine Spatial Planning Challenge as a method to explore emerging ocean sectors. Before I begin, I just want to acknowledge that this work is funded both by the Department of Energy as well as the National Science Foundation. And credit is also due to my amazing co-advisors, Drs. Linda Dana and Lindsay Dubs. So when we talk about data-driven ocean planning, we often emphasize the tools and technologies. But in the end, these decisions come down to the people, how they interpret this data, the values that they have, and the judgments that they bring. The rise of innovations like marine energy brings new layers of complexity. These emerging technologies compete with existing uses, and have a wide range of diverse stakeholders. But it's not just about the sectors, it's about how people make the decisions together. Games are one tool to move between data and decisions, and I'm here today to talk about one in particular in hopes of inspiring others who want to join me to bring this experience to their communities or organizations. So the MSP Challenge is a serious game that recreates marine spatial planning. Each player represents a sector, like shipping, conservation, energy, and fisheries, and works with others to develop a shared spatial plan in a fictional marine region. Teams use a variety of twine and tiles to represent different uses of marine space. The experience gives players insights into how planning decisions are made and negotiated, and how sectors interact. The game was originally developed in the Netherlands to support the rollout of the European Union's Directive on Marine Spatial Planning. So there's precedent for using this. One of the incredible things that makes the MSP Challenge so effective is that it takes place in a fictional sea, which is loosely inspired by the North Sea. That might seem like a limitation at first, but it's actually what makes the game so powerful. Because the setting is imagined, participants don't bring that strong pre-existing place attachments that was talked about in the last session, or the same kinds of political dynamics. Instead, they can focus on how sectors might interact and produce planning and practice planning in a clean, simplistic system. That makes the game scalable and transferable to many different contexts, including marine energy, without losing the complexity of the system itself. So marine energy, and here I'm talking specifically about energy sourced from waves and tidal currents, is an emerging sector that isn't yet on most people's mental maps for ocean planning. The MSP Challenge introduces it as a conceptual level, giving participants the opportunity to consider how marine energy might be integrated into marine spatial plans, including by introducing real-world applications such as desalination, powering ocean observing, pumping water for aquaculture, and providing electricity for islands or remote communities. Through gameplay, participants must think through where marine energy infrastructure could be placed, what spaces it competes with, and how it might coexist with other ocean uses like fisheries, shipping, or conservation areas. So gameplay supports the Atlantic Marine Energy Center's efforts to engage with stakeholders who have interest in existing uses and states of the marine environment where marine energy installations may be located in the future. Remember, this is an emerging ocean sector. The Atlantic Marine Energy Center is one of the United States Department of Energy's national marine energy centers and is a university-based collaboration between the universities of New Hampshire, Lehigh University, Stony Brook University, and the Coastal Studies Institute of North Carolina. These games contribute to research examining marine energy stakeholder engagement within planning efforts. So a little bit of the logistics on the game. The game works best with 12 to 30 participants, and the sessions run for about 3 hours, often a little more. It's meant for in-person events, and not particularly for student audiences or anyone under 18. The ideal participants are engaged in or adjacent to ocean issues. Again, anyone with a stake in the marine environment where marine energy could be located. The game supports people from different sectors and groups: energy, conservation, fisheries, local government, coastal communities, to come together to build a shared understanding of planning dynamics. The MSP Challenge creates more than awareness. At the individual level, it helps to foster a systems thinking approach to planning and builds empathy for those who we might not get to communicate with in our day-to-day lives. Within the group, teams develop a shared language, and tensions and values that are sort of hidden might be revealed. It's also an opportunity to experientially learn about marine energy. Participants often find themselves negotiating with sectors that they knew little about or defending priorities that they hadn't previously considered. These moments create shared learning and spark new conversations. Especially as marine energy projects get introduced, these kinds of conceptual, role-based experiences can help us broaden engagement and make space for new voices in planning. So I hope I've piqued your interest in the MSP Challenge. I'm currently looking to connect with groups or organizations who are hosting in-person events in the coming year where this game could be a fit. I'm especially interested in convenings that are aligned with ocean planning or marine energy, even if it's not the primary focus. Again, these should be with stakeholders who have interest in coastal environments where marine energy may be located. I'll cover the facilitation, you just bring the people. If you're looking for a fresh way to spark conversation, learning, and insights across sectors, I'd love to partner with you. During the lunchtime poster session immediately following this, I'll have some of the game components on display. Come check it out. Thank you so much.
Thank you, Jillian. What an interesting way to kind of break up presentation after presentation at these things. I encourage everybody to go take a look at Jillian's table, as they mentioned. And finally, last but not least, in this part of the session, we've got Tina Sepahpur from Maricus, who's going to talk to us about a really exciting kind of new project that Maricus is taking on in the Mid-Atlantic. So Tina, welcome.
Thank you for having me. Again, my name is Tina Sepahpur. I am the Wave and Water Level Manager at Maricus, and I'm going to talk to you about expanding water level monitoring in the Mid-Atlantic. So just to give you a little bit of an overview of what Maricus is, Maricus stands for the Mid-Atlantic Regional Association Coastal Ocean Observing System. We are one of the 11 regions under the U.S. Integrated Ocean Observing System, or better known as IUS. We are a nonprofit that partners with universities, government agencies, private and other non-private organizations from Cape Cod, Massachusetts, all the way to Cape Hatteras, North Carolina. And we integrate data from ocean observing platforms such as HF radars, gliders, buoys, webcams, and so on to focus on coastal hazards, fisheries, natural resources, maritime commerce and safety, water quality, and energy. Part of our wave webcam and wave buoys, sorry about that, wave webcam and wave buoy project, we are leading efforts to expand the water level monitoring across the region. So a little bit of our project overview. We are partnering with 5 leading universities to expand and enhance water level and wave monitoring across the Mid-Atlantic. Together, we are deploying low-cost water level sensors, wave buoys, current profilers, webcams, and building hydrodynamic models to better track and forecast coastal flooding. The data we collect feeds directly into tools used by emergency managers and planners to help communities better prepare for storm surges, nuisance flooding, and wave impacts. Ultimately, these efforts improve real-time awareness and support long-term resilience planning across the region. With that in mind, Maricus, along with our 5 university partners, aim to improve flood forecasting and early warning, support community readiness and adaptation, and then integrate this data into data platforms like OceansMap. And with that, I'm going to briefly go over each university and what they're doing as far as their projects. So the first one is University of Delaware. This is led by Dr. Jack Palaio and Dr. Alexandra Schuler. They have two goals. It's to assess local communities with coastal process understanding and provide real-time knowledge for data dashboard use, and install a wave buoy network for ocean offshore models and forecasting. To your right, you see those red dots. Those are the proposed buoy locations that they have set out to deploy those SOFAR buoys at, which would give us hourly updates. They are also looking at locations for water level sensors, and those locations will be set with the help of Delaware Sea Grant. So the first year is really just a lot of engagement, talking to folks and getting an idea of where to deploy these sensors. The second one is University of Maryland, which is led by Dr. Tim Canty. So this project is part of the university's HydroNet and Climate Resilience Network that built on the university's Grants Challenge Fund that started as a pilot program, testing sensors in Annapolis and talking to local partners around Maryland. The goal for this project is to expand low-cost water level sensors in Maryland and around Chesapeake Bay. Their focus is on data deserts, which are areas along the Chesapeake Bay that don't have any real kinds of sensors, let alone water level sensors. Through the Grants Challenge program, they have already installed 4 HOHONU sensors along the eastern shore, around like Crisfield and everything that we talked about yesterday. And then they're also looking at other sensors to deploy with this funding throughout other parts of Maryland. They're using flood models and engagement, talking to folks all over to figure out the best locations for highest needs for these sensors around Maryland. Next up is kind of a little bit of a partnership. So you have Stevens Institute of Technology and Monmouth University. This is led by Dr. Philip Orton, Dr. Laura Carr, and Dr. Tom Harrington. Their goal is to create a high-resolution shallow water barrier estuary model to improve water level predictions. They'll be focusing on data collections both in water and on land using a SOFAR buoy, ADCP, and water level sensors. And they'll be working with communities to identify sensor locations that best fit the community's needs. Along with this, they're utilizing data collections such as MyCoast, where they can collect photos with location and timestamps that will help them verify flooding in areas that are either close to tide gauges or even far away from them. And this way, they can help verify their flood model, which they hope to create accurate forecasts using the Stevens Flood Advisory System. Last but not least, Virginia Institute of Marine Science, led by Dr. Derek Loftus. So his goal is to focus on the southern part of the Chesapeake Bay where there's gaps in the water level sensor. He has a program called StormSense that focuses on monitoring flooding along the coast in the area. And with this area, there's a lot of rural areas with a dense urban population in between. And with these rural areas, they don't really have water level sensors, better yet, able to keep these kind of sensors. So, oh, sorry. Oh, no, I was fine. Never mind. Sorry about that. So they're not able to maintain these kind of sensors, so his main focus is to help these guys, and then also every year they're gonna be looking at different regions in the area. So like year 1 through 5, it's like Middle Peninsula, Hampton Roads, Eastern Shore, Northern Neck, and the James River. As well as doing the water level sensors, they're also collaborating with USGS with deploying AI machine learning webcams in years 2 and 4. These webcams can extract free surface elevation of water. So that is a new project that's coming along. VIM's Center for Coastal Resource Management also has a tide watch forecast model, which is a 36-hour storm tide forecasting system that helps validate flooding in different areas. And because they are very limited to water level sensors around there, they're really getting the community involved with recording where flooding is taking places, especially during irregular periods, and using this information to know where to put these water level sensors. And then we've only been halfway through the first year of this project, but we really want to focus on talking to people of different communities, different states, and getting an idea of what you guys need in order to, what you guys need and how we can help in order to be able to make these important decisions. We're here to listen, learn, and identify the data gap within the regions. And we'd love to hear your input and thoughts on these data gaps. Even if it's not water levels, it's something else that you guys may need, like, please come talk to us. We have a table set out to your left with information of what other stuff we're doing, getting your input, and then also we have oceans map set up, so it's a great tool to use. It's very customizable for whatever you may need. We also have Oceans Insight, which kind of breaks down certain layers for different areas. I know it can get a little overwhelming, so that might help ease that a bit. Or if you need help understanding how to mess with Oceans Map, please come talk to us. After this session, one of our PIs, Alexandra Schuler, is also doing a poster presentation during the lunchtime talking about her project. So it would be awesome if you guys came. If you had any questions, come talk to us. And then moving forward, we're just going to continue community outreach throughout all the states, continue working with our partners towards our shared goals. We will continue deploying the sensors and then working on creating workforce development through this project. And then another thing that we are doing as with different regions is working to standardize metadata across IUs, because I know other people are also doing water level sensors, and I know that's something we talked about, so that's something we're also working on. So with that, thank you. Here's my information, and if you guys need anything, please feel free to let me know.
All right, we're going to take a couple of minutes and do some Q&A for our first three presenters. Do I have any questions so far from the audience or even our virtual participants online? Mark?
So in context with kind of our first presentation this morning, Earth Law, you talked about spatial usage of the areas. You had only human spatial usage. There's a lot of fish tagging programs and migrations through those same waterways. Have you had a thought about overlaying those on your ship maps or your windmill maps and how they interact?
Yeah, it's a fantastic idea, and we've just scratched the surface of how you can start to look at the interactions between these different layers. I've seen some fantastic work that looks at how fish movements and fisher movements tell a coherent story, and how you can tell something about where the fish are based on where the fishers have been going, since we know a lot more about where the fishers are going than the fish. I think that's definitely a really exciting direction to go.
Other questions? Tony, go ahead.
Hello. Okay, there you go. One question on the game. Come back to the game, but first following up on the data gaps. I guess I wonder if you could just be a little clearer to me on the gaps. I mean, sort of what gaps are you talking about? Because I wasn't sure that claim really clear to me. And the second, maybe related question is, to what extent do you see the data needed to support the Delaware Ocean Plan needing to be different than, or how do you see it fitting with the Marco Regional Ocean Data Portal? So maybe how, obviously there's a lot of similar data sets, common data sets, hopefully you could just take a lot from the portal, but I wonder how you see at this point what the degree of focus might be for to specifically support the state's ocean plan.
Yeah, thanks for the question. There are so many fairly isolated gaps across management resources for different sectors, a lot of gaps in economic outcomes that we identified. I didn't want to go through those in the same kind of detail because it'd be a little bit boring in a context like this, but really what we were trying to figure out were, do each of these activities have the whole pyramid of data that they need in order to have future planning? And absolutely, Marco has had the deepest availability of that information. We found that there were a lot of older academic papers, though, that had some useful spatial information that wasn't in Marco. We found that there's a lot of graded data from Google Earth that wasn't there. There's really there isn't one source currently, and I think I don't think that there needs to be. I think that Marco is trying to position itself in that way. Really, all of this just needs to be accessible, so people know about where to go to get it, and that's going to be the future of making sure that these plans can be developed. I think you also had a question for.
Got my game question. Can you visualize that game turning into a virtual version of that game? Can you see that? Is that close, or is that a completely different thing?
Other way.
Sure. The question was, could there be a online digital simulation version of that game? The question, or the answer is, it already exists. This is sort of the physical board game of the MSP Challenge. There's a digital companion that was created by the same folks who originally created the board game out in the Netherlands, and that has a way higher learning curve for digital literacy, and so the board game version is really that opportunity to bring in folks from different sectors that might not have that geospatial background to be able to conceptually consider and build those initial foundation understandings where the digital simulation version might be that next step.
Hi, can you hear me? Yeah, hi. So I love the game. We actually developed something at the New York Aquarium for high school students to actually play physically. And so the students are given an identity and a piece, like a big cardboard cutout of a windmill or a ship or a fish or some other kind of animal. And then we set them loose on the beach, and they have a perimeter, and they have to act out that role with very limited amount of information, but they're told that they have to speak to whoever they interact with. So if they're a ship and they hit a windmill, if they're a fishing vessel that is interacting with bycatch, they have to talk to them and negotiate how they respond to that issue. And some of the animals get killed and they leave, the windmills get knocked down, whatever it might be, and then they come back and they do it again and they do it again. And the idea is for them to learn how to negotiate and understand the roles and interactions and how they have to work through these issues. So I'm happy to share those materials with you or anybody else who might be interested in taking it back to schools and playing with it.
Excellent. So, we can take additional questions at the end of the session. We do need to move on. I wanted to just draw a little connection here because I thought the question for Dr. Rising about what are the data gaps and how are they sort of being used by the Delaware Ocean and Bay Plan, I think that's a perfect illustration of how the work that we do functions, is that, you know, somebody like Dr. Rising would do a study, it would go to DENREC. DENREC then sits on our ocean mapping and data team where they are directly advising on, okay, we've just heard all of this information. We see that there are some information needs that could be incorporated into the portal, and we would provide some recommendations that would then be considered by, you know, the entire Mid-Atlantic OPC and the Marco Management Board for inclusion onto the portal. So I think that sort of stepwise iteration of this cycle of data, which Emily is kind of a good transition into. Emily, is Emily going first or are you going first? Emily's going first. Okay, let me get to her slides here. Okay, do we have Emily online? Can we switch the view here? And can we hear you?
Hello.
Hi, we can hear you. Excellent. We are waiting for the view so we can see you. One moment. While we are waiting for that, I'm just going to quickly introduce Dr. Emily Shumchenia. Emily leads the portal in New England for the NROC data portal. Many of you may be familiar. This is a very analogous tool to Marco's data portal, which we're talking about a lot. Emily is also the director of the Regional Wildlife Science Collaborative. We work very closely with her often, and we're excited to hear from her today. If you could expand that so we can see Emily, that would be great. Perfect. Okay, Emily, take it away.
You can see my slides okay, too?
Yes, we can.
Excellent. Hi, everyone. Thanks for having me today. Just to introduce myself a little bit further and maybe explain the range of logos on the title slide today. My affiliation is with NROC and RWSC, but of course, as Avalon just mentioned, RWSC is co-hosted by NROC and Marco, and ROSA, the Responsible Offshore Science Alliance, is essentially RWSC's sister organization, as we like to call it, where we, RWSC and ROSA, focus on similar topics and engage similar participants from agencies and industry, but where RWSC focuses on marine life, marine wildlife, ROSA focuses on fisheries. And of course, you'll hear from Renee in a little bit. But what I've been asked to talk about today is more specifically about how the data governance work that each of our groups does is connected and collaborative, and why this collaborative approach we use is needed, what improvements it will result in, and so on. So also what I'm about to talk about is part of a much bigger presentation and body of work that we're building. I'm going to provide probably a very limited number of examples because of the time today, and Renee's presentation, I think, will build on this, but know that we have this bigger collection of examples and a bigger portfolio of this work that spans many ocean data types. So we're also interested always in continuing to gather use cases about good data management and stewardship to inform how we move forward, to inform where we concentrate our work, how we make recommendations. So if any of this resonates with you, please reach out to any one of us, and I have our contact information at the end. We also want to note that NROC, Marco, RWSC, and ROSA are working very closely to actively fundraise to support improvements in ocean data management infrastructure, informed by everything I just said, all of the knowledge and case studies that we're building, and the examples that you all in the community provide to us as we dig in. So we like to refer to this collective work as one to advance reliable maps, data products, and ocean data systems for business, government, and research decisions. So NROC and Marco have been around for around 20 years and have been working with many ocean users and experts to create data products for the portals. There's also been this more relatively recent effort by RWSC and ROSA to characterize the data landscape for offshore fisheries, wildlife, and environmental data out there. And that's the context for why we assemble these working groups and subcommittees. Each of us does our work through these much smaller subsets of participants and individuals. And they each have roles that contribute to this sort of cycle of data production and use that Avalon referred to. We can start sort of at the top of this diagram by talking about how some of the groups really focus on identifying ocean data needs and how they need to be used to make decisions or inform any sort of process, either government or business decision, right? And then maybe other working groups take those pieces of information and develop maps and data products to inform and serve those needs. And oftentimes, they're taking existing data, right? So NROC, Marco, RWSE, and ROSA aren't really producers of raw data. We're going out there and taking existing data streams from agencies, from private entities, from industry, and we're saying, this is what we've found across the region, and we're going to develop these maps and data products to address the needs we're hearing you all articulate. And then in doing that, we learn a lot about the data management infrastructure, right? Because we're digging into where those data are stored, whether or not they can be easily combined into a regional map, and so on. So we're also, sometimes this is happening in a similar group, assessing that infrastructure and understanding what the practices are that were used to get the data in that place in the first place. Then we go on to actually develop from that assessment recommendations. So we will often go back to a data provider and say, you know, what would be really great is if you did blah, 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 blah. And sometimes that's more formal, and sometimes it's more general, where we can look across how data are stored and make recommendations for how that could be improved by adopting or using more modern infrastructure or different practices and so on. And then sort of the final step in this cycle that we've put on the slide here is the need to continually track and coordinate what new data might be collected by any number of entities, but that would eventually get fed back into updating data products or creating new data products and maybe even informing what ocean data needs and uses exist. So we've described this as best we could as a continuum. It's a gradient. There often aren't these very discrete steps, but we did that to simplify it so that we could talk about it. And sometimes there are groups that do more than one of these things, or they do parts of each of these things. But we wanted to lay this out and provide this picture because our groups really do interact together on this cycle in important ways. And so this slide now takes that same sort of cycle and says, like, who's doing what parts of this? So when we think about identifying ocean data needs and uses and developing those data products, that's where we mentioned NROC and Marco and their committees and working groups are really doing that and have been doing that for the past many years. And when we get to assessing the infrastructure for data storage and data management and recommending practices, that's really where RWSE and ROSA have stepped forward, certainly when it pertains to marine life, habitat, and fisheries data. For other data types, there may be other groups that are more suited to this role. And then for the tracking and coordinating and understanding what new data are coming online and what new data are being collected out there, all four of our groups are really play a role there. And again, sometimes it is sort of divided by, marine life, habitat, and fisheries, or the RWSE and ROSA wheelhouse, and then other ocean data types are NROC Marco wheelhouse. So what we've learned from this over the years, and some of this is obvious, there are many funders and collectors of ocean data. So talking to all of them, as many as we can, and understanding their processes, we've built an understanding of what research and data collection activities are being funded out there at any given time. We have pretty good connections with the major funders and the major folks that are doing the data collection. We've learned a bit about their analyses and data product development preferences, or their capacity and how we work together to develop those things that you eventually see on the portals. And we've learned about their data management, storage, and accessibility. And you won't be surprised to hear that where there are lack of standards, lack of requirements, and lack of adequate infrastructure to house and manage data, it makes it really difficult to develop and maintain data products on a regular schedule, and sometimes at all. It's very difficult to create a first version in some cases because there's just so much work that needs to go into collating existing data among many different sources. We do want to note that there are some examples that have worked really well, and we've come across these in our work over the years. I'm calling out a few on the slide. What I'll describe to you verbally is the map is a map of the Blue Topo product. That's a product that is developed by NOAA. It's available on Now Coast. It basically takes all of the best bathymetry data. I'm just showing a snapshot of an extent of it too. It's almost nationwide. And it takes the best of the chunks of bathymetry data that numerous entities are collecting, and it essentially stitches them all together in a uniform, unified, synthetic product that is so accurate it's used to inform navigational charts, but it's a great product for researchers and others to use as model input. We're starting to see it show up in models as an input, and it's repeatable. Every time new data are collected, it's almost instantaneously integrated into this product. They actually have a companion layer that you can activate in the Now Coast map that tells you when the specific chunk of data that you're looking at was most recently updated. And I find that it's always in the last couple weeks or months, the constant updates. So they've developed this workflow that we recommend a lot of folks develop conceptually, where you sort of have this centralization or standardization of a data collection protocol and a QA/QC protocol, and maybe you collaboratively develop the analysis steps and you collaboratively develop the data products that result from those steps, but you make it repeatable and easy to update so that you're not spending tons and tons of time redoing work every time you need an updated data product, which in some cases is every couple weeks or months when data are being collected rapidly on certain topics like we're starting to see now. So then we get to the challenges, right? So how do we talk about that? I only have a couple slides on this. I'm going to use seafloor data as an example. I know you all had a topic yesterday that focused, or a topical meeting yesterday that focused on seafloor data. What we've done in many examples is essentially talk about what the challenges are and how those challenges are inhibiting use of the data or inhibiting decision making, which is important to describe because sometimes it can feel abstract. Yes, data management's bad. What does that mean to me? And the examples we've collected from talking to data providers, data users, and that spans industries, government agencies, researchers, and so on. So this seafloor data example, you probably talked a lot about this yesterday. There are many uses for seafloor data. We're seeing it in habitat management decisions, seafloor planning. Industry uses it to make business decisions where they're going to put a cable or whatever. Cultural and archaeological applications, and of course, research applications. There typically is a long lag time between when the data are collected and made accessible. There are many and could be overlapping databases and repositories where you get this information. Not all existing data are archived in a publicly accessible way. We've heard stories of, data are on hard drives in people's offices. Data have different levels of accessibility among the sectors for privacy reasons or sensitivity or proprietary reasons. And these data are usually expensive to collect. It involves, lots of field effort. So what is this resulting in? It means that decision makers like agencies, tribes, and businesses don't have access to the best available information in a timely fashion. It means that some seafloor data products are being developed with incomplete information. So they have data from some, but not all, and they don't have access to all the data for some reason, and so they leave it out. Other models, like species distribution models or hydrodynamic models, habitat suitability models that rely on seafloor data, are using very coarse or substandard information because they don't know about or don't have access to a product like Blue Topo, or that even Blue Topo is too coarse for their application. So a lot of real world impacts, and we've heard sort of anecdotally, just most recently from an internet service provider company, for example, that was planning a new cable route, requested a chunk of bathymetry data from the data portals in an area where they're interested in, potentially planning a cable, and that chunk of data wasn't completely processed and ready to be shared. So they're sort of at a crossroads now where they might need to consider resurveying the area and recollecting the data because they need it urgently to make a business decision. But what's sort of frustrating is that we know the data exists, and it exists in some form that could inform their planning, but it's not able to be released yet. So we're talking through, sorts of case studies like this with folks to learn more about how we can support, play a role, and make recommendations that might improve these types of workflows. And just to translate, all of that, all of those considerations and all of those steps into what specific groups in our organizations would do any of these things related to seafloor data, right? So NROC and MARCO have ocean planning committees that each have seafloor planning subcommittees. They're the ones identifying needs for the decision makers. NROC and MARCO each have seafloor related subcommittees or committees. And NROC has a submerged cultural resources working group. So those experts and those individuals are identifying the needs, they're informing the development of maps or developing them themselves, and they're helping us track and coordinate who's collecting data where. And then, of course, we have RWSE and ROSA on the bottom. We each have committees or subcommittees that relate to seafloor data, but we're really focused on assessing that infrastructure, recommending practices, and again, contributing to the awareness of who's collecting data where and disseminating that information. So just a reminder of how all of that fits in and how all of our organizations sort of contribute to this cycle together. Wanted to just throw some discrete results and recommendations out there. So they're not always going to be labeled as this is a recommendation for an improved data management infrastructure piece, but RWSE does have a page on our website that's dedicated to research and data coordination and supporting data management and data governance. And on that page, we have an intellectual property publications policy that has some really good practices in there for data management and infrastructure support. We've created other standardized language for anyone to grab to put in their research agreements or contracts to ensure that data are interoperable. So this is part of that cycle, but kind of really finely embedded in it. Not one of those obvious steps, but really important to ensure that the folks you're working with and that you're funding take these steps. Glossary, metadata guidelines, and then an assessment of repositories that exist for marine life and habitat data. This is one of those things we're going to be building out as we continue to talk to folks and build these case studies and the resulting recommendations. And then finally, a data management and sharing plan. It's the worst thing that no one likes to fill out a data management and sharing plan. It's a grant requirement for a lot of federal agencies. RWSE and ROSA are requiring it now for projects that we fund. It's often an afterthought, but we're trying to get it front of mind for folks and have everyone sort of recognize and help us actually learn more about some of these data systems by filling them out and following them. And that's where I'll end. I have our contact information here. Like I said, if there's anything you want to discuss related to your experience in the ocean data system at any of those steps, we'd love to hear about it. Thank you.
Thanks, Emily, and hopefully you can stay on for after Renee's presentation, where we will do a brief Q&A. And if we could put this back on the share screen so we can see Renee's slides, that would be wonderful. Okay, excellent. Let me do this. Okay, perfect.
Thank you. Avalon and I are different heights, so. So how's everyone doing? I'm less formal than everyone who's spoken this morning, so bear with me. And I also am a PC user, and so James was so very dignified in not calling it out, but I certainly know that there are going to be some slides with some things moved around, so bear with that. And I'm glad that Emily had a slide with RWC's specific products. So you won't see them on mine. I just went through and it's going to be an adventure, friends. All right, so my name is Renee Reilly, and I lead the Responsible Offshore Science Alliance. We are a nonprofit that is a little bit different in terms of both its history as well as its composition to RWSC. So we're kind of, I say sisters, and sometimes maybe I should think about the metaphor of cousins instead. But I love this framework that Emily shared, and you might be wondering, you know, what could we possibly add? I feel like she really gave this amazing overview and background. And so my job today is to share with you specifically the fisheries examples behind what Emily just described in terms of processes. And so I think data governance sometimes, maybe not for this room, but we always feel like we have to sell it or why it's exciting or why folks should care about it. And so I thought I'd take a step back and just talk about fisheries data in general. And I was going to crack a joke about I am not a graphic designer. This is not actually one of the mistakes. This is just Renee making a really ugly smart art. So anyway, fisheries data are generated and used by a whole host of actors, right? Federal and state agencies, academic researchers, indigenous communities, the fishing industries, NGOs, private industries like ocean developers. And good governance, what we mean by that is having clarity on who owns the data, who stewards the data, those are two separate things, and who accesses those data. And so the decision-making that we're talking about today really, depends on each of those steps being clear. And so a key issue is that distinction between ownership and stewardship. And so I just wanted to highlight that. Again, I know I'm likely preaching to the choir with the composition of this room, but ownership is often, the folks that are retaining that funded or collected data. And stewardship is this long-term responsibility to maintain the data accessibility and quality. So that may fall to government agencies, data networks. In the case of acoustic telemetry, which all of our fish friends are really used to, that's the telemetry networks. And this distinction is really sensitive when we come around public-private partnerships or when data are used to inform regulatory or management decisions, i.e. in fisheries management. So I think this is a really good kind of case study and example for us to think around and go from that big abstract to something more concrete. So laws like the Magnuson-Stevens Act for the fisheries management councils, interstate compacts for the Atlantic States Marine Fisheries Commission define how data can be used, including confidentiality provisions, and good governance ensures compliance while enabling all this great collaborative science we're talking about. So that's kind of the backdrop. I do want to just share about ROSA specifically that our inception as a nonprofit 501c3 was actually a partnership between the Responsible Offshore Development Alliance and offshore wind developers. So that's our history, is these two user groups. RODA, the Responsible Offshore Development Alliance, is a trade organization for commercial fishing. And offshore wind development is a relatively new ocean use here on the Atlantic coast, and so those two groups really have different perspectives on how the ocean maybe could, should, or will be used. And so they essentially sat down. It was a government shutdown, actually, so there were some furloughed federal employees around the table too, and said, hey, how can we put science first, right? Best decisions are going to be informed in good science. And so ROSA was formed to serve as this objective resource across sectors and really facilitate the coordination that we've all been discussing. And so our 4 guiding principles are there on this screen: to be scientific, objective, collaborative, and transparent in all we do. And our organizational structure is important to this story because, again, when you're trying to make decisions around challenging, planning solutions, you need to have the right folks around the table. And so we are led by a board of directors that provides the fiduciary and mission oversight that has equal numbers of fishing industry and offshore wind developers, as well as folks from BOEM and NOAA and state organizations that help lead the mission of the organization. But really important piece of how ROSA functions is our advisory council. And this is the body that gives us kind of that strategic decision and priority setting, and has representation from each of the states on the Atlantic coast. Because of our inception being around offshore wind, we also have ocean developers, we have commercial and recreational fishing representatives, the regional fisheries management councils, ASMFC, and so all the folks that are really using these data around the table to help us make the right decisions around data management. And so with that collaboration in science, we really are working to improve our understanding. So one of the key things that Rosa created that I think is an important tool to highlight today is our Fish and Fisheries Offshore Wind Research Database. RWSC has a really analogous database of wildlife research as it relates to offshore development. And this is a one-stop shop for both all of your research that's happening around ocean development and fisheries, but also priorities. So Tony, I love the question around like, what is a gap? What are we talking about when we say research gaps? This tool was really created to quantify and allow for a formal gaps analysis to understand where we are in terms of all the amazing work that has been done, but still where do those gaps lie? And by a gap, we mean, is there a research need that's been published in the peer-reviewed literature or by states that, or the federal government that hasn't had work to address it? So we've conducted a formal gaps analysis in 2024, and then went out to our community, our advisory council, our research advisors, to ask, what do you think is most important out of those gaps? So this is a really exciting piece of work that helps us to inform our own funding selections in terms of future work, but it's also a tool for the broader community around ocean science and understanding regional assessments of fisheries work. So what's in there? There's 221 projects. We just pushed an update in January. A lot of that is the individual monitoring that's happening associated with ocean development. There's 139 other research and monitoring projects. Folks like New Jersey RMI, NYSERDA's direct research in terms of not just monitoring, but also looking into, all kinds of questions like access for fisheries. But at the same time, the database has this group of research needs, 323. So that's the gap. And we did the formal work to match those and find out what needs have been addressed and what have not. But as we were doing that, it kind of brought this huge question to bear of how do we start thinking about all of these data in terms of organizing them and relaying the outcomes of them to the folks who need to make the decisions. So we chose to organize the groups of research projects by method. That's just a good way for us to wrap our heads around things, and created some data governance work. So, this did come through. That's exciting. So, as Emily mentioned, there's a joint best practices guide that ROSA and RWSC have created. It's on our respective websites, a one-pager that has kind of like, here's a minimum of if you are collecting these kind of data, here's how you really should be handling them, right? So minimum, better, and best scenarios in terms of guidance. We both share data policies that Emily just described, guidance around data sharing, including the DMSP that she just described. And I think this is just the very beginning steps. So why we're here to talk to you all today is that this isn't something, as Emily mentioned, that is an afterthought. Like, we collected all this great data, what should we do with it? We need to really be thinking about the work we're doing in terms of data management from the front end. And so here's just a snapshot of what that one-pager looks like. And the reason I want to highlight this in particular is that acoustic telemetry is a tool that's being deployed really extensively, and I think is an important example of a regional sort of infrastructure type of a project. So if you're not familiar, it's kind of like Easy Pass for fish. I don't know who coined that, but it's not me, so credit to them. There are receivers out. As a fish swims by, it has a tag that pings, and you know the fish has been there. So they use that for not just fish, of course, and so having this similar guidance from both the wildlife and fisheries side of the house means that we can really optimize those infrastructure deployments. We can really optimize the questions we can answer at different levels of the food web system or of the ocean system, and linking the ocean processes to the outcomes for the natural resource or eventually for the fishing industry itself in terms of outcomes is really where we would like to get. So our data governance program, I have a QR code if you want to check out the website. It is in its early phases. We kicked off in February and set out with 2 working groups that just got started this spring. But we really are here to kind of invite you all to come to that table. You all are the folks that we would love to have included in those conversations to recommend things like documentation around metadata, how we can have projects really organize and structure their data sets, any other specifics to be included in terms of cataloging the experimental designs that folks are using with their respective projects, because all of those things help us interpret the data in a more meaningful way. How are we going to be good managers for our future selves? That's a huge question around data and data stewardship. And how are we going to preserve and publish data to answer more regional questions? And so I really invite you to, reach out to all of us. Avalon and I are here in person, and Emily and Nick are available via email, but we really hope that you guys will not only, if you're not the right person, we always say you probably know the right person, and so please engage with us, sign up for our newsletters, and let us know how you might want to be involved. And I wouldn't be wearing my ED hat if I weren't to shamelessly plug our upcoming data governance briefing. This month, we are going to kind of cover those core tenets and policies of our strategy, how we're working to ensure fair data principles, provide a little update on the progress that the working groups are making. It's easy to talk about and very hard to do. Gets into the weeds almost instantly around this stuff. And so we're doing our best to really keep it exciting and engaging so that folks continue to not only engage in our processes and listen to the guidance that we give, but help us co-create it, right? The best solutions are co-created, and so we really want to enroll the community in that. So please register. There's a QR code there, and I have like 19 other slides that I'm going to just hold off on, so we can have more time for questions. So thank you so much.
All right, thanks, Renee. Can we put Emily back up on the screen so we can do some questions? And I wanted to open the floor now for some audience questions. Any questions for Emily or Renee on data governance, data management? Ryan?
This is Ryan from Virginia. I'm wondering, one of the things that we've been hearing about is an interest in trying to, broaden the audience of folks who are participating in research, participating in monitoring. And so I'm wondering what y'all's thoughts are on how do we, set up our data governance, set up these processes so that they don't, prevent that from happening. When we talk about trying to bring commercial fishermen, there's talk about Indigenous Guardians programs around the Chesapeake Bay and monitoring that they would participate in. So is that part of the thinking that you guys have developed, that we're setting this up in a way that we want interoperability, we want transferability, but we also want to enable people to come from the place that they are coming from and still do good work, at whatever metric they're working off of?
So if I could maybe jump in there. I think the respective pages on research coordination are a really good place to start. And yes, we absolutely, at least from ROSA's perspective, think that cooperative research is the best research. We have specific guidance and language for how to make meaningful partnerships with fishing industry members as part of your research. And that's not just contracting a vessel. Everything from the experimental design through to actually even before that, what research questions are most important, all the way through to the data analysis. It's easy to think, well, this person's knowledge is not necessarily applicable in those ways, but actually it turns out it is, and there's so many great examples out of Northeast Fisheries Science Center's Cooperative Research Branch to demonstrate that. And so we have some guidance on our website, and we also have folks that are on our advisory council that have expressed that they're very willing to connect and help advise how to do that in your region.
Other questions for Emily or Renee? We have a couple questions for the other panelists, but I want to get to questions for Emily and Renee first. In the back here, Joe.
Hi, I think this question's for Renee. Can you go into the details on the formula or the process to find those data gaps that you showed up there?
Yeah. So we partnered with our colleagues at WSP to essentially take all of the published research priorities and create summarized research needs out of it. So from that 323, it's been condensed down to around 100. And then there was a formal matching process so we essentially went through and said, okay, we're not going to call a research need addressed. We're not making that kind of subjective label, but we are separating things into whether or not they've been explored and the degree to which they've been explored. So for example, in a given research category, there might be, and I have this on a slide, I'm not going to run them back up, but 70 projects around the impacts of just whatever, EMF or something like that, right? But in another category, there might not be any. And so a true gap is a research category or need, summarized research need that had no work in it. And so all of the details around that analysis are under peer review this summer. So if you are interested in being on the peer review panel, please come and find me. We're holding that in June and July to make sure that we've caught everything and represented the research needs that the folks who put them out there intended. And yeah, I hope that answered the question. So we essentially did a matching process, and then at the end, we have kind of things that have been explored and things that haven't. And then we have some varying degrees of exploration. So there's quantification of how much a given project has been or need has been explored.
Tony McDonald, again, it's so exciting to see all this coming together and the convergence of this. Congratulations, just great. Kind of the question I have is, I think the model is fantastic. First of all, I think we maybe do ourselves a disservice by talking about governance and frameworks. This is knowledge creation and an integral part of research, so I think we need to continue to stress how this is really going to actually generate knowledge as a result of this. So it's not just a bunch of rules, but so I think that's just really exciting. And that gets to my question a little bit. I think maybe there's something that's coming up, and we'll talk about eDNA next. You talked about acoustics now. At some point, working into that circle, technology and innovation, because sometimes technology and innovation around the applications and the use of how you do research and the data development may be a really dynamic factor of either accelerating or focusing on any specific aspect. So I come out of a planning mode, so I love starting with the needs. I love it. But on the other hand, I think there may be thinking about whether and how, I wonder if you've thought about that, because there seems to be a lot of potential out of autonomy and visualization and data analysis, AI and framework, things like that, which, let's not get confused by that or distracted by it. But I wonder if you've thought about how you bring in that technology and innovation around the data itself and ways to do it.
Emily, you want to take a crack?
That question didn't end up where I thought it was going to go, Tony. I thought you were talking about innovation in collecting new data, and I was like, that cycle makes the case for why we need to do this, because technology usually results in more data. But I like where you went with it, leveraging the technology to sort of help with some of this or help with the synthesis. That's part of our suite of recommendations, is that we don't really see a lot of some of the new tools that you mentioned being leveraged to improve data management quite yet. There are definitely cases where it is, and I mentioned that Blue Topo project was a NOAA ocean data dissemination project, which was like meant to inject specifically what you said, new data management technology to develop a solution, and it's the success story of that. So the fact that we're using that as our case study, I think, reflects that we know and we're recognizing that data management technology and data handling technology, whatever you want to call it, is going to be a key component of fixing some of the issues that we're seeing. Because it's, and you can think of, like you mentioned eDNA, but also when we were talking about seafloor imagery, we're collecting way more data than we can manually analyze at this point. So, technological solutions are going to need to come into play in that cycle, maybe at every step and in different ways.
Thank you. We have time for one more question, and then we are going to break for lunch. And I do apologize. I know there's others that we didn't get to, but.
So it's Mark Casey. When I go out on my boat, I run my Garmin, I come back, I connect it to Active Captain, it goes up into the cloud, and it's available to all the other guys that are running. Is that Garmin and other type of bottom typographical mapping coming into your data?
I can take that one. I doubt it. No, I don't think it is. And part of what we're seeing are the proliferation of a lot of individual tools and individual data communities for specific uses, but a lack of that recognition that, like, oh, maybe the data I'm collecting for my particular purpose could actually answer other questions too. And that, I think, also relates to what Renee said with their research database and trying to really understand, if you're studying one thing with a specific goal, why can't that data be used to answer other questions too? So we are definitely suffering from many, and this is an overused term, I hate myself for even saying data silos, but we're definitely suffering from that problem as well. So our assessments of what data are available need to be broadened, and the different apps they're out there now that are allowing data to be shared among various groups more easily now should definitely be leveraged. That needs to be part of our assessment. There's a lot of potential there and a lot of work to do. I don't have an easy answer, but it should all be part of the equation for sure.
Renee, did you have a thought?
Yeah, just to add that's absolutely something that we're considering at multiple levels too, because for example, we were talking largely about those fisheries monitoring plans related to ocean development. Those data can still inform regional assessments and be leveraged to support NOAA fisheries surveys, and so we're actively working on those solutions as well. So I think it's true at the individual recreational fishing industry level, and also at the broader state survey and federal survey levels too. Great point.
Thank you. Thanks to our panelists for today. Again, sorry for the questions we did not get to, but again, really appreciate your time.